This view looking back up at the outside lip of the 150-meter-tall rim of Jezero crater was taken by the Perseverance rover on May 15, 2025. The bright-colored rocks exposed across the slope, running from middle left to middle right of the image, belong to a formation the science team calls the Broom Point Member, a 75-meter-thick stack of ancient rock. This sequence of layered bedrock is likely more than 3.9 billion years old, making it among the oldest terrain ever examined by a Mars rover. Evidence uncovered by Perseverance indicates this thick section of rock was built by repeated asteroid strikes, with layers tilting at nearly vertical angles exceeding 80 degrees due to the subsequent colossal impacts that created the Ascites Basin and Jezero crater on Mars. The findings offer a view into one of the most tumultuous chapters in the history of the solar system. Since leaving Jezero, Perseverance has been exploring a brand new frontier, both geographically and geologically, a chapter of Martian time that predates the crater itself. On Earth, the earliest geologic history has been fundamentally broken up, deformed, and erased by plate tectonics. But because Mars lacks plate tectonics to recycle its crust, this ancient record remains intact, giving a rare glimpse into a geological time period that doesn't exist on Earth. The Broom Point discovery came after Perseverance began ascending the western rim of Jezero crater in late 2024, where the rover began examining surrounding locations with its science instruments. The data at Broom Point revealed 6 distinct rock types, including breccias, rocks composed of angular fragments, alternating with layers of fine-grained, pulverized rock dust. Rock fragments within the breccias are pocked with gas bubble cavities, indicating they were once molten. So the presence of tiny, dark, glassy beads within the layers offered an important clue about how these rocks formed. While volcanoes can produce similar glassy droplets, they rarely occur in such high abundance, pointing to asteroid impacts instead as the primary architect. In fact, the largest beads rival those flung out by the dinosaur-killing Chicxulub asteroid's impact on Earth. The repetition of these distinct rock types, multiple times throughout this thick sequence of rock, indicates that high-energy impact events happened again and again across this region of early Mars. The different rock layers are a record of variable-sized impacts occurring at different distances from where this rock sequence was accumulating. Some large impacts took place very far away, some small impacts nearby. Their debris all ended up landing here, constructing this thick section of rock. How these layers formed may suggest an interaction with water or ice on Mars. Several of the layers look like they may have been formed by fast, ground-hugging debris flows. On Earth, these powerful, fluid-like surges can occur when molten rock hits water or ice that instantly flashes into steam. Some of the rock's layers also tilt at angles exceeding 80 degrees, nearly vertical, which is far too steep to be caused by the impact that created Jezero crater. Instead, scientists suspect a cosmic event shaped this landscape long ago. First, a colossal asteroid impact created the 1,900-kilometer-wide Ascites Basin, one of the largest impact basins on Mars, upending and tilting the once flat rock layers. Later, a second asteroid likely struck, forming Jezero crater, which measures 45 kilometers across. This second impact fractured and uplifted the already tilted rocks into the dramatic formations the rover sees today. To pin down exactly when these events took place, the Perseverance team collected 2 core samples, dubbed Bell Island and Main River. If a future mission were to return them to Earth, laboratory dating could determine when and how often impacts were occurring on early Mars, and by extension, the infant Earth, whose own early impact record has been erased by billions of years of plate tectonics. During this violent era on Mars, it wasn't rain or snow falling from the sky, but an almost constant barrage of molten rock droplets and pulverized dust kicked up by asteroid impacts. If scientists can pin down the ages of these layers, it would be like reading a cosmic weather report from 4 billion years ago. Captured by the multispectral imager instrument on NASA's Psyche mission, this image was acquired on May 15, 2026, during the spacecraft's flyby of Mars. Psyche was traveling from right to left, northeast to southwest on Mars during the 6 minutes that it took to acquire this image. The imager used its near-infrared, green, and blue filters, which helped to reveal highly contrasting craters, ridges, wind streaks, and volcanic plains materials on the surface. The image covers part of the Iapija region of the rugged southern highlands of Mars, from approximately 62 degrees east to 78 degrees east longitude and 4 degrees north to 14 degrees south latitude. The largest crater just below center is called Fournier and is about 71 miles, 114 kilometers in diameter. The linear feature running from top to bottom of the image just left of center is part of a long irregular cliff system called Onatria Scopuli, which is part of the circular structure of the large Asides impact basin to the northeast of this area. Gullies on Mars are small, narrow channels in their downslope sediment deposits found on steep slopes, especially on crater walls. They resemble channels carved by water on Earth, and they generally have an hourglass shape made of an upper collection area, alcove, and a lower fan of debris. Scientists study Martian gullies to understand Mars' ancient climate and water cycle. Gullies located in the sand dunes of Matara crater on Mars are very active. One large gully seen here in particular has had major changes in every Martian winter since HiRISE began monitoring, triggered by the seasonal dry ice frost that accumulates each year. This time there was an especially large change, depositing a huge mass of sand. The sand divided into many small toes near its end, or perhaps many individual flows descended near the same spot. Additionally, a long sinuous ridge of sand was deposited. This could be a levee that formed along one side of a flow, but there is not much sand past the end of the ridge, so it might also be the main body of a flow. River deltas on Mars, like the one seen here at Jezero Crater, are the best places to look for signs of past microscopic life. That's because they trap organic matter, sediments, and microfossils perfectly. A delta forms when a sediment-laden river runs into a body of standing water, and as it does so, slows and can no longer hold the sediment, so it drops the rocks, gravel, and soil into the water body, which gently sinks to the bottom and forms a delta. Over time, the delta becomes a layered repository, like a book with pages, which one can turn over each day to learn more about the history of Mars. So how does a delta achieve this? Well, the rocks and sediments had to come from somewhere. They were sourced in a region called the watershed of the delta. This is a much bigger area than Jezero Crater itself, about 45 kilometers across, and the rocks seen in the delta will inform NASA scientists about a wide range of Martian process, and some rocks may even be older than the Jezero Crater itself, about 3.9 billion years old. This might happen, for example, if a very old rock is preserved in the watershed and then is broken off by water and then carried by that fluid into the river and finally into Jezero Crater. If scientists do get access to these super old rocks, then this would be a very interesting thing for the Mars rovers to sample for eventual return to Earth. Another incredible possibility is that scientists may find fossilized traces of ancient Martian life in these delta rocks. In one scenario, life might have got started in the early Noachian period, about 4 billion years ago, when Mars was probably more friendly to life and was preserved in the watershed until one fateful day when they were washed into the river system, and then the crater. Exploring river deltas, therefore, is very exciting for every scientist, because any of the interesting rocks found in these landforms could hold signs of life on Mars.